Okay, welcome to the second half. We continue. I think we had what, six students. So we'll go on. Who's the next person, Kap?
The next person is Pilanut.
Pilanut, okay. Pilanut,
sorry.
Girl, Pilanut, the boy. Okay. Okay, you have the floor.
Let me just share screen first, and let me recap from what I said in the last class. So what I'm doing right now is emerging technology for aging society, and from the report from UN World Population, it states that in the next 30 years, the percentage of world population over 69-year-old will be double. And the problem is those seniors have weak health and are unable to go outside to hang out with the community. And actually, my father also have that problem. He really want to go to surf, but due to his mental health, bad health, he can't pay even how much he want to pay. So so that was the matter. And actually 43% of seniors feel lonely, and half of them have a greater risk of death. So I'm thinking about using VR technology and other technology to make a virtual world to keep them feeling like they still be a part of the community. And how does it work? Well, I'm thinking about making social VR world to keep elders engaged with the community via the internet and help them be able to roam through the virtual world with friends instead of living alone at home. And for last week, I have done deeper research on how does work and what technology that we need to bring this project to reality. And honestly, to make this project become feasible, it requires technology that might not exist yet or fully developed yet, like VR glasses that have a feedback or feeling when the user touch 3D object in virtual reality. And yeah, like we also need a higher efficiency CPU and higher internet, higher efficiency. And I think the idea that I left will be benefit to elders by keep them mentally sharp, avoid depression, and also help to stay in touch with their friends while they stuck at home. And in the conclusion, to solve loneliness in elder, we could use metaverse to connect them to the community, even though they may not able to leave home often, but they can still feel involved and be a part of the community. That's what I got for now.
Oh, you know, I have if you notice, I have not covered metaverse in this class, and I'm kind of like on the fence a little bit about, I'm kind of watching it, this space in a sense, but so maybe this project would be a good way for you to actually become, I guess, educated with the metaverse technology set. So how much of it is well, first of all, you have to understand that metaverse has been around for a long time. It just hasn't been called that way. When you guys play games and buy tokens and all that stuff, you already were operating in a metaverse. So this metaverse is something that's very much endemic to the new generation of, people who play multiplayer games and all kind of stuff and all that. And I think so between that and the VR technology, so all this. So what is metaverse exactly in this setting? Is it just sort of like a virtual reality enhanced multiplayer platform, right? Plus maybe some kind of secure payment. Now, ultimately, the reason that all the big players are getting to metaverse is because they want to have real economy operating in the metaverse. Okay, I don't mean to be cynical, but if you get your grandpas into the metaverse, there's going to be a lot of people selling them insurance, right? And think of how bad. I mean, we already have that. You have people trying to sell your grandma and grandpa something like endowment fund for the grandchildren and all kind of stuff. Hard selling, investment products. So that can happen in the metaverse just as well. But so there's a lot of, again, pro and con. It's kind of new tech, new area. Another aspect about metaverse you have to explore is the concept of I guess interoperability. In other words, well, ideally, okay, if you think of say Facebook becoming metaverse, what they try to do is somehow create a super platform that absorbs all the multiplayer play games and all that stuff into it, right? Now, maybe that's not necessarily a good thing. Maybe your solution would not be to use say Facebook's metaverse solution, but maybe develop a local metaverse, right? A metaverse that only applies to your grandpa and your grandson. Okay, think of computer network. Okay, just because it's connected, that doesn't mean it has to be universally connected. You can have LAN, local area network, right? So even though you take the metaverse as a concept, it doesn't necessarily mean that you immediately jump to the Facebook version of metaverse, right? So maybe there's a technology that you can think, maybe it's a solution that says this metaverse is a metaverse just for your grandpa and the grandchildren, right? Your own private family metaverse. And this is secure, this is isolated from the bigger metaverse that, allow people to sell home insurance to unsuspecting grandpas or something like that. You see what I mean? So try to approach this from not necessarily skepticism, but to understand that metaverse doesn't always mean the metaverse that's being pushed to you in the media, right? So think of abstract to the level of technology, think about it. So maybe what you want to do is just multiplayer game for your grandpa to play with the grandchildren, maybe, I don't know, right? So there's a lot of variation in that. So get response from your friend, from your class, and how are they, how are they playing? Have they gotten into this metaverse hype? So talk with your friends.
Well, so let me ask an opinion from Nontagon. Do you think this concept can really help your parents or your senior?
I think my parents will gain a huge benefit from this idea. It's like, my mom always stay at home and all she can do is like call her friends. So maybe she can use this metaverse or VR. I think my mom gonna be happier since she can roam through the virtual world with her friends instead of just calling with them. Yeah.
Any of you guys in the metaverse yet, or whatever? I mean, the metaverse. Oh, multiplayer games. Are any of you into that? No? I can't believe Basai students.
Yeah.
Who?
Yeah, me.
Good. Okay. Give us a lowdown on what you're doing there. Maybe that will help.
Playing with other people from other part of I don't know where, but still can able to communicate and do something together. And I think it's kind of like a metaverse in some way. It depends on what you think metaverse is. If it able to communicate and just stay with other people, I think we will have metaverse all around the world through games or maybe like communication platform. But if you classify metaverse as you need to do an VR and shift your body to there, I think it's still in depth. I think it's on the perception of what you think metaverse is.
By the way, I like to give you guys a sort of like a comparison between what's happening in metaverse and what's happening in cryptocurrency. You guys remember that, you know, I'm very enthusiastic about cryptocurrency, blockchain technology, but I stopped being enthusiastic at people treating Bitcoin as a speculation, right? So in other words, within the system of cryptocurrency, it's very elegant, and I think it's very nice, the way it was conceived and engineered and all that. And then it got a little bit silly because people don't play within that system and they just put in real money to speculate in Bitcoin. It's a little bit like that. If you imagine games, you used to have tokens, right? Tokens are earned in the games, right? You play games, you earn token. Maybe you become a good player, you earn a lot of tokens and you can exchange, right? So there's a little economy of little tokens within games. Now, it gets a little bit less creative and perhaps dangerous when people just use real money to buy games token now, right? I have a niece who asked her dad and mom to actually, you know, use a credit card or whatever online payment to buy tokens for games, right? And this is why it gets perverted, right? And this is where I don't really like this kind of thing. So there's a lot of creativity that's happening in the game community, but you know, once people become lazy and say, well, you know, I can't really go to the next stage without this token, so I'm just gonna, you know, use real money to buy tokens, and that's when it gets I think it gets counterproductive and it's not imaginative. So there's a little bit of that. Okay. So again, I love the idea of virtual community or virtual reality, a universe of interaction and identity. This is all cool, but when you start, you know, having something with the real universe interaction, for example, again, you can have two girls in the virtual environment, but when you link to reality, like, okay, now that we become friends in the metaverse, let's meet in real person. It turns out when you meet real person, the other girl is a pedophile or something like that. Okay, so when you link from virtual system, this is beautiful. It's wonderful. It's creative. To the real system, sometimes it just leads to something really terrible, and that happens. Okay. Okay, Cap, how are you doing? So who's next, Cap?
Okay, next is Piranut. Oh, sorry. Pantisha. Okay.
Pantisha, right?
Pantisha.
Yeah, so I'm gonna share my screen. Can I? I think, oh yeah. So this is not my actual screen, it's just the screen that I made. So you guys can see what I'm doing right now. Doesn't update one. So what I'm currently doing is about doing an rational protein engineering of ISP test. Reason why I do that. So wait a second.
Go ahead, Cap. Sorry, I'm back on the internet.
Oh, okay. I understand because I actually used July Wi-Fi and it crashed. a lot of time in your class, and I'd be like, okay, I will just use my telephone.
Okay.
Yeah. So
Okay.
polyethylene or PET produced by the polymerations of ethylene glycol and tetrahydride is one of the most produced and used plastic in the world because of maybe like various guarantees that are transparency, durability, low cost, and easy portability. However, as the production and consumption of PET continuously increase, the non-biodegradable plastic waste accumulates in the soil and oceans, causing severe environmental problems. So therefore, to solve this environmental and health problem, several techniques have been developed and research have focused on the biodegradation of PET as one of the solutions. Nowadays, lots and lots of PET hydrolytic enzymes has been reported, but this enzyme exhibit limited PET degradation performance due to their substrate specificity. For example, cutinase 2 form, I may be pronounced it wrong, it's thermobifida fusca has such a high PET degradation and peak activities, but only exhibited in high temperatures like 70 degrees Celsius. However, PETs from Ideonella sarchisis, I will find further what caused which is present in this slide. It is reported to have the highest PET degradation activity under moderate temperatures, around 50 degrees Celsius to 25. But there's still some concerns on its low thermal stability that still limits its utilization for plastic waste management. So what I am going to do is to develop ISPTS variants that enhance thermal stability and remarkably improve PET degradation ability. So how I'm going to do with that, I'm gonna use rational protein engineering process to develop the variants. But I think I need to just talk a little bit about it. What is rational protein engineering? It's basically a rational design is a particular strategy in protein engineering which attempts to create improved protein molecules based on the three-dimensional structure. It's normally used with the protein that already have the structure data in the database, and then we use computational models to identify and visualize it. Then we target what we're gonna change in that specific area, and then we generate it, simulate it, and then we use it in the practical world. And that's how rational protein engineering works. So I didn't do the next slide, but the methodology of it I didn't research. I still on the process of researching, but basically, in order to improve ISPTS thermal stability, we need to attempt to identify the key structural features affecting the low thermal stability of protein first. By rational design strategy for enhancing the thermal stability, So we're gonna search in the database of this particular protein. Then we just gonna find which part that affect the thermal stability of this protein. And I actually find some research about that. So I'm gonna show to you guys. It is this one. Okay. Oh, it's the wrong one, sorry. Wait. I'm not sure which slide it is showing. Is it the paper one?
Yep. Rational protein engineering of thermostable. Okay. Yeah, share that with us as well.
Yes, it's basically what I want to do is similar to this one. I think what I can do is just change the variants of it, because in this type of experiment, we normally do just change the type of bacteria or change the type of plastic or change the variants of it, because we need to experiment like the range of the variants so that we can find the optimal one to do the task, which is degrading plastic.
Wow, it's very exciting.
Yeah.
I think last year there were you know, the first science was that I think some Japanese scientists discovered bacteria that ate PET, but it was digesting at a very very not scalable. So instead of relying on bacteria, you just go directly to the enzymic mechanism. The emerging technology here, by the way, is enzymic optimization. Okay, so it's a little bit like last week we talked about the metabolic pathway, right? That's sort of like identifying the pathway. In the same way, you have enzymic science, so discover the enzymic mechanism. Now, enzymic optimization takes it to a little bit another level. Well, not another level, but sort of like to the more engineering aspect of it. It's not just discovering how enzyme does things, it's how to optimize the process so the enzyme can do things maybe better, faster, or in your case, at lower temperature, right? It's always something about this. It's always about scaling. It's always about, you know, if you think about it, I don't know if you know about this cold fusion thing in physics. Well, fusion can be done, but hot fusion is not, you know, something they want. So they want to do hot fusion at lower temperature. So it's called cold fusion, okay? And that sort of thing. So there's always this kind of trade-off in engineering where you find out that A can perform task B, but not under condition C, right? Like A can do B under very restricted condition, very high temperature, very, you know, that sort of thing. But can we do a version of A that does B under condition that's less restrictive? And that's when it becomes a game changing, okay? And that's where scientific discovery of 1950s, okay, that stay dormant because it's not scalable, it's not doable, all of a sudden become emerging technology, right? And that is a story of emerging technology as well, okay? So you can think of, I think, maybe less than 10 years ago, I think, when this bacteria was discovered. So that's the science. The science is the bacteria and the enzyme that perform this task. But it's going to become at some point emerging technology when you can get it to scale up, to do things at lower temperature, okay? It's the same thing with, you know, you read this thing, you know, packaging, it says this thing is biodegradable. Well, technically, some of the things that's biodegradable, it's only biodegradable at high temperature and high pressure, right? If you throw it in the landfill, it's not going to biodegrade because it doesn't have the temperature and pressure. So this is very, very interesting, very exciting. I think that there are many groups around the world working on this. I happen to know that there's a group in UK, I think Bournemouth or something, University of Bournemouth, active in this area. So many groups are into this sort of thing. It's very exciting. Yeah. So this is a beautiful story, right? There's a scientific discovery of bacteria. There's a scientific investigation of what exact enzyme does this, and there's a sort of like engineering implication. Well, can we make this at lower temperature, at a higher and more stable condition, right? So we don't want enzyme to just eat PET in a lab. We want it to eat PET in a landfill, right? And this is exciting. This is very exciting. I mean, I can see that, you know. Let me ask you this personal question. Okay, remember I told you about Basai student being four layers, right? 4 levels. Okay, sort of like an educated consumer, social transformer, entrepreneurial technology to entrepreneur, and literally innovator in the space. Are you thinking that perhaps maybe after Basai you can literally go into a master in microbiotech, that sort of thing? Are you thinking about that? Okay, in that case, I don't know who's your academic advisor. I mean, could be me, or, you know, if you like. But certainly what you should do is don't wait for Basai to form your curriculum. Try to actively see if you can maybe cross-register it with microbiology department or labs, right? This is something that I really want to happen to Basai student, right? Basai will give you the framework to go broad and deep in certain area. But once you decide to go deep in this area, that area, you're not going to find depth in here. Maybe you can find a little bit of that with me in data science, but certainly enzymic optimization, you definitely have to go across to the other side of the street, to the science department, right? Be active, okay? Be active. Now, bear in mind, Basai only started 4 years ago, so there's a lot of teething problem, right? Can you register, cross-register? Are they going to allow you to do this? That could be an issue. See what happens. But try, be active, work with your academic supervisor, right? Now, if you don't have one, I can be yours, if you know, to help with it. But I'm really not a bio a tech guy, so I really know nothing, virtually nothing, right? Okay, so work with your academic advisor. Try to get a second, and the best thing is not just to be able to cross-register with Department of Science. The best thing would be to actually get a real academic advisor from that department who's actually looking after you. Okay, that would be lovely. I don't know if we have that mechanism yet, but if you can get an academic advisor assigned to you from Department of Microbiology or something, you know, you can go really far. You can go really far, right? Good. I like this. I like this a lot. I like this a lot. And it's going to happen. A lot of technology is going to be a little bit like this, okay? Because you are not going to have deep solution. Okay, first of all, you're not the only solution to this plastic pollution. There's going to be other solution, behavioral, right? Social engineering, right? Maybe something like mechanical engineering solution, just, you know, getting mechanical sieves to filter plastic as it goes from river to the ocean, right? Or, you know, compacting, or robotics that does the PET sourcing. You know, we actually have technology like that now. It's just a little bit expensive. It can literally scan. You know, you can have a sort of purveyor of plastic bits, right? And depending on optical detection, say, okay, this is PET. I'm gonna blow it to the left bin. This is not PET. I'm gonna blow it to the right bin. So that sort of technology kind of exists. Now, how expensive, how cheap, how scalable? Again, this is all. This is and the funny thing is this. The funny thing is, emerging technology is a non-linear story, right? It's a non-linear story. In other words, from here to there, you have to overcome 500 hurdles. Okay, you have to overcome 500 total hurdles from this original scientific discovery to, you know, scalable garden variety PET ether. Okay, but the story is not linear. It's going to be like you have first 100 hurdles. It's going to have to be solved. Maybe you get to 200 hurdles, and out of the sudden this becomes scalable, and the other 300 hurdles just happens just like that. Okay, this is what emerging technology does. And it's a very non-linear thing. Okay, and there's always a moment, and every single area you can mark it down to the, maybe not the 2 months, but at least to the year. I can do that with AI. You know, in terms of like visual recognition, I can say, well, you know, I can mark it down to 2012 when the curve becomes like this, you know, from steady improvement, overcoming hurdles to boom. And then everything else is just refinement. Okay. That year hasn't come yet for enzymic degradation of plastic. Okay. The 2012 in visual recognition AI hasn't happened in your subject yet. Okay, that may be 2030. I don't know, maybe 2027. I don't know. Okay, but that's coming. It's coming. It's coming. Okay, very good. Very good. And you can be there when it happens. Okay, and you can make it happen. You can be part of what makes it happen. It's very exciting. Okay, who else?
Thank you.
Okay.
Have you sent the paper to share with your friends? Yeah, share the papers with your friends. Okay.
Oh, of course. I will send it to your line group.
Okay, Kap, excellent.
Should I begin now?
Yes, whose turn?
Chalanton.
Chalanton. Okay, Kap, you're up.
Okay, so the topic that I'm going to be presenting about the IoT solution is about shipping operations, which is about a new standard of measuring the parcels. So the pain point that I found is that when you're shipping a parcels, like the measurement standard is totally at randoms, and that lead to an inaccurate pricings and unfairness to both customer and service provider. And the service provider, they also lose their credibilities and also customer loyalties. And why do I think this is important? Because capturing an accurate dimensional measurement is one of the core of successful shipping operations. And whether a shipper use vendor box or its own standard size packagings or pack in a box of various size, it needs an accurate dimensional data to ensure compliance and avoid fines or unfairness to both customer and service provider. And I found that the root cause, there are three of them, which are equipment, materials, and environments. So from the equipment, sometimes the equipment for measuring, it is in a cooler or under temperature conditions. And sometimes it's not regularly calibrating scale. And sometimes there are various sizes of parcel to measures. And in the materials, there's no universal standard of packaging materials. And when you measure one item, and sometimes people assume the same weight across all variants within product families, and which sometimes is not true. And for the environments, there are unpredicted moisture conditions. And when you measure in an environment, the product is not intended to be stored. Sometimes the result is not accurate. And when you measure a parcels in a warehouse, at the highest leaf, they have a significantly warmer than a lower shelf. So from interviewing one of my friends, I discovered that the dimension measurements has no standard at all, especially when you pick up the parcel in the front door, they just kind of like use their own guess. And the most important thing is the customer who using the shipping deliveries, they don't know that this is the pain point, and they don't know that they're losing the benefit from this factor. And sometimes there's also a human error, because sometimes employees, they see their own regular customer, they wouldn't bother checking for the parcel dimensions or weight, and they charge the same price as before because of the trust and the laziness. And there's no universal standard because some shipping company doesn't have, or they don't do the dimensions. They just do the scaling measurements. So first I did a research and I come up with 3 IoT solutions. So the first one is the tablet camera audio sensors. This was developed in 2013. It was quite a while. So what this is the system can tell the dimension from a camera view of the tablet. And the system, we use the speaker and microphone sensors as their distance detector to gather the data from measuring. And the system will also use the acoustic pulse as for microphone and the microphone's vibrations. So then, as in this picture, when you scan, and it can detect the vibration of the microphone and receive the accurate measurements. But when you apply to shipping, we're not gonna hold it like in this picture. We're gonna apply it and put it stationarily in the conveyor belt. And from the experiments and from this picture, it has shown that the most error that it can have is only 0.6 centimeters. The second solution that I found is called a light cutting methods. So basically, it's the same thing. It applies the same thing. You put it stationarily in the conveyor belt, and how it works is you use a laser beam to scan the object, and will receive the reflections by using the CCD, or what's called charge coupled device. It is the IoT that can capture pictures and turn the elements into a pixel to capture. It can also scan and detect the depth and the roughness of the object too, and that is what is really good for. And lastly, the solution that I believe that everyone knows, which is LiDAR camera sensor and at conveyor belts. So what LiDAR sensor is, it emits pulse light waves from a laser into environments, and these pulse bounce off surrounding objects and return to the sensors. And those sensors will use the time it took for each pulse to return to the sensor. It calculates the distance it travels. And how do you use it? You place the AR LiDAR cameras on top, width and length of the conveyor belts, and so that the customer can just simply place the box on the belt. When you're setting it up, you need to calibrate the system first with something with a fixed high accuracies to match the camera pixels to the real objects. When talking about accuracies, if the parcel measure a length of 10 centimeters, there are plus or minus 1 centimeters of inaccuracies. And this, we only talk about the iPhone LiDAR. And the more expensive the LiDAR is, the higher the accuracy it can get. So the IoT solutions that I picked that I think it is best to use is the LiDAR camera sensors, since it has a really high accuracy of dimension measurements. There are many big companies use these technologies and apply it to their industries. It's not too high of a cost. It is really easy to use and install, and many developers and researchers are still improving and researching mainly on these technologies. There are also a large communities of people who use and interested in these technologies and wanting to integrate it into a wide range of projects or industries. So therefore, in the conclusions, I believe that if this IoT was first used in delivery transportations and it can work efficiently, it will bring a lot of tractions, and in the future, customers from other transport that doesn't use this IoT will demand and ultimately make this universal and used everywhere. Thank you.
Excellent. Okay, Pat. Yeah, let me just make one comment, which is that I think this IoT. Okay, here's the thing. Every business has cost, right, and revenue. Okay. The theme of IoT is what's called granularity. Okay. Now, when you have no granularity, it's something like this. I would charge you $100 to deliver a package anywhere. That's absolutely no granularity, right? You have more granularity, I would charge you $50 per kilogram anywhere, right? More granularity, I would charge you $50 per kilogram within Bangkok, but $70 per kilogram anywhere else in the country. You see what I mean? So I think you have to think of the big picture of what IoT does. IoT is giving you granularity, more detail in space and time. Okay, so presumably, you know, if you get to infinite granularity, it will be something like, you know, this thing weighs 2.75 kilograms, has to travel, you know, 174 miles from this city to some guy's house. And for this, you can calculate that it's going to cost the company exactly 3.7125 baht or whatever. Okay, it's that kind of granularity. You're not going to get to that point, obviously, but I think you can think of IoT as giving you sequentially more refined or more granular information. Okay, so that's undeniable. I think that's the thrust of your project, is the idea that with IoT you literally, you know, now that doesn't necessarily mean, okay, let's say you're operating a curry or something like that. Let's say you have fine-tuned information about exactly how much it's going to cost you to send this package that distance. It doesn't mean that it immediately translates into finer granular pricing if you have no competition, right? So think of it this way: even if you have this information, but let's say you are a monopoly, okay? It used to be a monopoly, this packaging delivery service. You may not have any incentive to do price discrimination, you know, like charging by the price, because you can say, you know, everybody is going to pay $50 to deliver 1 kilogram anywhere, and that's like a maximum distance. So if you get minimum distance or lighter package, you would just net the difference. There's no competition. So you have to think of it as two things. First, with competition, maybe you can undercut your competitor, right? Because your competitor doesn't have this granular information, so it can only charge in blocks of kilograms in city, okay? Whereas you can literally fine-tune your pricing, so you can charge less for something that weighs a little bit less, something that travels a little bit shorter distance. You see what I mean? So in other words, with no granularity, how do you charge? How do you price your service? Well, you kind of have to go to the maximum, right? Maximum, because not everybody's going to deliver a package from here to Chiang Rai, sometimes to Ayutthaya, sometimes to Pathum Thani. But if you charge a flat fee because you don't have granular pricing, you have to make sure that it covers the cost for sending package to Chiang Rai, right? But if you have more granular, then you can, you know, price per distance and so forth. So I think that's how IoT is going to give you competitive edge, through increased competition. Okay, so that's something very interesting. Okay, now it depends on who owns this technology, right? If you're a monopolist, you own technology, you're not gonna, you don't have any motivation to reduce your price. But if you're a newcomer, and that's where newcomer comes and disrupt whole industry. Okay, so this is also another theme about emerging technology: more granular information, more precise, distance, time, weight, whatever. Okay, the more granular detail you have information on your cost, the more you can undercut your competitor. Okay, and then you become a new player. And this is where fintech makes the best case for, not fintech, sorry, startup tech makes the best case for disruption. Okay, because remember I told you that technology doesn't have to happen in a startup, right? Biomedical research, it's very hard to come up with a startup solution. You have to work in a big pharma to come up with a solution. But this is one of those where startup is better, because if you're a big company, you don't have incentive to even find out this kind of detail or more granular pricing, because you're already a big player. You beat everybody already. You're the Curry, you are the whatever, Amazon, or not Amazon, DHL, whatever. You already own the sector, so you don't have any incentive to innovate. Okay, so this is where startup can really innovate, because startup is the only way they can make a win. The only way they can beat the big guys is from this kind of thing, undercutting the price by better information, and that's what IoT is going to give you. Okay, same with data science. That's going to give you that as well. Yeah, so this is very good. That's quite exciting. Okay, what we got? Who's next up?
So, Shalathon is the last person, so we have no more queue for today.
Oh, okay. So do somebody not show up today? Okay, never mind. Here's the deal, Cap. Today is class 14, right? So tomorrow is our last class, but I want the last class to be presentation. So what I'm going to do is cancel tomorrow, right? Cancel tomorrow, and then have the, what day is that? Next Thursday. Next Thursday is your project presentation. Okay. Now, after project presentation, okay, you will have, I think, I'll look at the timeline a little bit, but certainly you have like a week, I think, to the final exam, right? So the exam is gonna basically, well, we can talk about the exam for. I'll come back to talk about the I guess the exam coverage and all that. But the idea is that for the final class, it's a presentation, but you don't have to deliver the document yet, right? So let's talk about what I really want from the final project. Okay. So for that, let me be the one sharing the screen. Okay. So let me. Okay. Any more discussion from your friends? Okay, we have pretty good time today to discuss, because we kept everybody to strictly 15 minutes. So you can discuss among yourself and all that. Okay, but if not, I'm going to be sharing the screen. Hold on, let me start. Okay, so let me just share this thing, and let me just share this. Okay, right. So 2 things we have to do, right? Project and final. Okay. Project and final. Okay. So what the project is going to consist of, right? So again, what am I looking for, right? What am I looking in for? So first of all, okay, what am I looking for? Okay. As with any kind of assessment or evaluation of project, it's going to come to really 2 things. Okay, it's always about quality, right? It's usually not about quantity. It's always about quality, but there are 2 kinds of quality. Okay, I'm gonna I'll give you a little understanding, a little concept here. Quality is equal to completeness. Okay, so I'm always looking for quality, right? Any kind of thing, assessment. So let's talk about assessment. Okay. Occasionally about quantity. Okay. But usually it's about quality. Okay. And it's usually quality multiplies by quantity. So it's always about like this. Okay. but this is the thing that cannot be zero. Okay, so in other words, it starts here, and this is an integer, right? You have more of it. Okay, you have one piece, or you have 2 pieces. Okay, or you can have 3 pieces, or you can have 3.5 pieces. Okay, but the quality has to be there. Okay, so this is kind of like quality piece. So it's always, this is how you always assess. So in this class, quality. Okay, quality over quantity. In other words, if you did your job well, you don't have to do many things. I'm happy with this. Okay, this is how this. Okay, so that's the first thing I want to tell you. Okay. In general, in this class, okay, let's put it this way, much higher, much. Now, so let's talk about what's quality. There are 2 qualities. Okay, quality is completeness. Okay, quality completeness, and okay. Now, impact, I'm going to put in double quotation because it's a very big word, in which case it means it implies a lot of things. Okay, what I mean is this, roughly speaking, okay, roughly speaking, this means wow. Okay, wow factor. Okay, so in other words, I'll just give an example. I'll give an example. Okay, because I really like, say, this idea of I think two-dimensional polymer, because it's a new thing. Wow, that's a cool thing, right? Or this enzyme eating plastic. Well, this is the next big breakthrough, right? The big year is going to come in the next 5 or 10 years. Wow. Okay. So the impact is sort of like the impact to the audience or someone who's assessing the quality of your work. Okay. So that could be your friends, me, your TA, right? So this is the interesting thing, right? This is what's going to make me remember. Okay. But there's also this thing called completeness. Now, completeness is a little bit like professionalism. Oops. Okay. In other words, your idea may be very boring. Your project may be very boring project. Okay. So no wow factor, right? But you did a good job. The presentation is good. The survey is good. You're not just writing, I want to do this, but you say, what have people done in this space? What are the obstacles? These are the research. This is a backstory. This is the survey. This is what the technology is. This is where the players are. These are the issues that they ran into. You've done a good job of doing a survey, background survey. You've done a good job of explaining the technology. Okay, so the technology can be very boring. Okay, so no wow factor whatsoever, right? No wow factor whatsoever. Okay, but you've done a good job. So this, okay, good research, good presentation. Let's make it clear. Presentation. Okay, so overall, you have, you know, key message or, you know, objective achieved. Okay, So whatever you set out to do, it's complete, it's done, it's thorough, it's professional, and so forth. So good research, clear presentation, well, let me put it's a good research, clearly presented, etc. Okay. So I can't criticize for this. I can't criticize you for this. You've done a good job, solid. Okay. So I put the word solid. That is quality. The other quality is the wow factor. So in other words, okay, new insight. Okay, new insight or innovative. All right, and this is where you get words like, oh, this is very clever, innovative, okay, game changing. Okay, if you hear words like this, okay, the presentation may be terrible, okay, but the idea is really good. Okay, let me give you an example. Pantisha started, again, today it's not about presentation, but if this were a presentation day, Pantisha jumping right to the enzyme, that's a terrible presentation. I have no idea where you're heading. I happen to know where you're heading because I'm interested in this area. Okay, but if I'm not interested in this area, jumping immediately into the enzyme work of that means that's completely, you know, I have no idea what you're talking about, right? So it's not a good presentation, but that's okay. Today is not a presentation, but I'm not picking on you. I'm just saying, you see what I mean, right? Something can be really wow, but the first 5 minutes, what are you talking about? What, you know, what's the enzyme got to do with this and all that? Okay, so you have no story, you have no presentation, organization. People just jump right in, right? That's no good as a presentation. Okay, so next week, of course, you do presentation. You have to do a background, you know, the problem. Now, on the other hand, some of your friends can start with, you know, template, right, of project. Okay, this is the pain point. I want to address this. I want to do this. I want to do that. That sort of thing. So the quality is going to be like this. Okay, quality. Okay. So let me call type 1 quality. Okay, it's not a real word. Quality. Okay, type 2 quality. Okay. Now, okay, fine. So that's in general. That's the assessment. Okay. Likewise, in this class, okay, this class. Now, deliverable. Okay. So this is going to be what's the day today? Today is 27. What's the? Wait a minute. I think we have next Wednesday or it's next Thursday, right? Yeah. Okay. So May 2000, May the 5th, right? I think. Yeah. 1, 2, 3, 4. May the 5th. Okay. May the 5th. Presentation. Okay. And let me just. Let's say your exam is on the 12th, right? Okay, so let's say I give you until Nakat. Okay, don't hold me to this, okay? But I might move this back later. Okay. In class. Okay, this is a document. Presentation. Okay, document presentation. Now, there's also video presentation. Okay, the video presentation, I'm gonna say, if you can deliver it before, it would be great. But let's just polish it. Okay. In other words, in previous class, in some of my previous class, you make the video, you show the video, then you discuss. Okay, but in this class, I'm just gonna say, well, in-class presentation, you just do it live. Okay, the video is for later. Okay, so even though this in previous class, I may have done something like this. Okay, but I don't think it's gonna work. So this video presentation. Okay, now I don't want it to be document. Now, if you send me everything on the 20th, okay, I'm not going to be able to evaluate them all. So what I'm going to say is something like maybe the 16th. Okay, maybe. Okay, so those things. Okay, video presentation. So this video presentation is like your takeaway. You can have this on a YouTube. Right? By the way, to put this on YouTube. Okay, so I'll give you the format a little bit later. So it could be something like EmergingTech. Okay, I'll tell you guys later. Okay, we did this last year as well. So you would upload it under EmergingTech project or something like that. Okay, and then your name or something. Okay, so we'll talk about that. Now, this is gonna be 5 minutes. Now, it doesn't have to be exactly 5 minutes. It can be 10, but it's that kind of thing. It's not a deep narrative. Okay, this is sort of a pitching thing. This is where there was a project about the traffic, right? Imagine that you have this 5 minutes. Okay, you are approaching Department of Transportation, and before you start your talk, you can play this 5-minute video. Think of it as that kind of video. Okay, so full project documentation. Okay, so this is going to be paper plus code if you have, plus data, plus code, plus etc. Okay. So for example, let's say example of the traffic. Okay, so the traffic problem. Okay, you have the paper of what you want to do. Okay, you maybe have a data set. Now this data set can be public. You extract some of it. So all this certainly is going to have to be zipped together. So maybe there's a folder of paper, there's a CSV file of the data, and maybe a mathematical code that highlight congestion. Okay, it's just some kind of data to display congestion. So you have a code, something like that. So at the minimum, paper. If you have more than this, certainly, okay, you can add artwork, you can add whatever, okay, but chances are for this class, you can just deliver some paper, okay. So this is kind of like, that would be cool. Okay. But I don't expect everyone to do this. Okay, so deliverable would be that. So next project. Okay. Now let's talk about finance. Okay. Now, what exactly do I want to look at? What do I want to look at? What do I want to assess? In general, it's always this, by the way, okay? Okay. Now, retention, I think you're quite used to this. If I'm teaching you, you know, history of medieval church, and I give you a lot of facts and figures, right? Retention is how much of it you actually retain in your RAM, okay? Now, not in your hard disk. In your hard disk, it's like you can Google it later, you can open the book, but how much can you retain the information that I've taught you for the old 10 classes? That's retention. It's always this. Okay? Retention. Okay? Development is how you grow, right? Did you grow from the beginning to the end? Okay? So the development. Now, the development is a little bit hard to assess, right? It's sort of like, I can't test you how smarter you are before you take emerging technology and how much smarter you are. So this development in this class, okay, in this class, development, okay, means, right, let's do this. Let's do this. Let's say retention, okay, will be focused on two things. Okay, focus. Retention, in terms of retention, let's say in terms of retention. In terms of retention, we have two things. A, okay, topics. But I'm going to put that as number 2. Topics, for example, what did we cover? What? Micromolecular, let's say molecular biology. Okay. What else did we cover? Robotics. What else? Nano science and tech, right? Whatever. So that's the topics. Now, in terms of intention, what else do I want to do? Remember, going back to my mind map. What is my job, or what am I trying to do in this class? What am I giving you? What do I give you? Okay, let me go to my mind map. Okay, can you see my mind map? Okay, oh wait, I'm not sharing the whole screen. Never mind. If I share the whole screen, it's gonna be because I have a double screen. So better yet, I'll just give you, okay? What do I want to give you? Anybody? Come on, raise your hand. I gave you 3 things. Schema, framework, and library. Right? 3 things I gave you, right? Schema is, perspective, look at new technology, right? Emerging technology. Framework, remember framework, for example, let me give you an example from the framework part, okay? Well, how about the framework to look at emerging technology as starting kit, right? There's different area. I'm not gonna review that for you. You can review that yourself. So under the heading of emerging technology starter kit, right? Well, what do we need? We need the math, we need the invention, we need the social acceptance, right? Where does emerging come from? It's what? It's a supply and demand, right? Supply of technology, material, production, demand in terms of humans and system. Do we need it right now? That's when you get. So these are way of analyzing. So to go back to this, Pantisha plastic eating enzyme, Okay, you can address this as emerging technology starter kit. And when you go to the things like in terms of demand, in terms of human demand for it, in terms of a system demand for it, it's already there. You don't have to work on it. You don't have to educate the consumer. You don't have to educate the consumer very much. Just say, hey, I have wonderful enzyme that eats plastic. I mean, that's already going to get everybody excited, right? So let's say the demand is there, the supply is not there. The supply of technology, again, and what do I mean by supply technology is not there? Sometimes the math is not there. Sometimes the science is not there. Sometimes the engineering is not there. In your case, is the science there? Yes. It's the engineering that's not there. Okay, so you use this. So in my assessment, right? You go through this thing in well, just look at the IEC mind map. Okay, see the class mind map, right? Okay, now I'm not going to ask you to say, well, IPSI, right? Ingest Pro, right? That's the first. I think that's number one. That's number one framework. I think probably, right? Ingest Pro, Survey, Imagine. So if I'm going to test you on this, okay? Let's say on framework, okay? Ingest. What is, okay? I'm going to ask you, what is IPSI? Okay, and then you tell me, okay, just Pro, Survey, whatever, Imagine, okay? That's not going to be a very interesting exam, right? So I'm not going to ask you directly. That comes to here. In terms of development, or some teacher like use the word growth. Okay, so in terms of growth, okay, this is how I'm going to test you. Able to apply at least these two things to your topic, the research project. Okay, so chances are in the final exam, your answer will definitely not be the same, because I'm going to ask you to apply the framework to your topic. And because you have different topic, right? And nobody's going to have the same answer. That's easy. Okay, so you're able to apply this to your topic. Okay, now something is not going to be tested here. Not here. Okay, so not able to utilize library in your project. In other words, my library, what did I give you the library? I gave you the, well, first of all, Mathematica, that's a library, right? The notion of going to Earth Observatory resource, that's a library right there, library of Earth observation data, right? So if Kushi, right, show this, but you can't show this on exam, but you can show this in your project. Okay, so example, Kushi used Earth Observatory data to play with CO2 retention map or something, I don't know, okay, whatever the project is, okay, something like that. Now, this is not going to be, this is going to be in the project, so it's not going to be on the exam. So the exam is going to be a little bit more about this, the schema and the framework. Okay, so the schema, again, there's things about, usually it's about readiness of emerging technology, and what else? The pitfall, the unintended consequence. Okay, so for example, unintended consequence maybe, I'll give you an example. You develop a game that hopefully lengthens the attention span of young people under 13. Okay, unintended consequence maybe you get them even shorter attention span, or parents no longer care about monitoring students' digital information, because they think, okay, well, we've got an app now that helps cure everything. So parents will like outsource their responsibility. So that could be, so there's a lot of unintended consequence. Okay, so this concept of putting things through, say, sufficiency economy philosophy, right? Moderation, causal nexus, right? Resilience. Okay, you can apply that. So my exam, one of the exam could be something like, okay, run your project idea through the triple loops, moderation, causal nexus, and resilience of sufficiency economy philosophy. Run through that, make the analysis. So able to, so this case framework, e.g. the triple tree principle of SEP, for example. Okay, so I can ask that. That's going to be certainly a very good exam question. Right. So anyway, so this is how it's going to be. So I'll give you a little bit format, just so that you can. And I'm going to restrict this to maybe no more than 10 questions for sure. Okay, chances are I might ask just 5 questions. Okay, but you have to go deep. So essay, it's going to be kind of like essay. Okay, probably something like no more than 10. Okay, probably 5. Okay, probably 5. It's gonna be like that. Now, you will take it on, I guess, exam template, right? Exam template. So it's not ideal, because some of the idea you should be able to draw like graph or something like that, maybe some kind of visualization, but we're working with limitation. Okay, so this is where you're gonna have to take, I think, what's the exam mechanism again? I think the app, not what check appอะไรนะ it's gonna be online, so a bit like your midterm. What's the program? What, Exam Plus or something like that?
Exam Plus, yes.
Okay,
yes.
okay.
Exam Plus.
Okay, good. So I think, and that's gonna be the 12th, right? Okay, so that's it. Okay, so I'll send this to you after class. Okay, so that's it. I think we're done for the day. We've got 10 minutes left. So what I might do is just briefly briefly, let me reshare, but I'll go to this thing. Okay, all right. So again, okay, the schema is here, the frameworks are here. Okay, all the classes is organized. These are all the resource, right? The resource. So the library introduction. That's very good. Okay, but right. So again, I'm not going to ask you to tell me or describe this in pure form. You know, what's IPSI cycle or what's sufficiency economy? What are the three principles of sufficiency economy? I'm not going to ask like that. I mean, that's kind of like too easy. I'm going to say, tell me through the lens of sufficiency economy, the causal nexus, how you analyze the causal nexus, okay, in some aspect of your project, right? So the causal nexus for you, something would be, well, I have to establish that there is a causal nexus between playing video too much and ADHD. That has to be established. I have to also establish that gamification of attention lengthening exercise does lead cause effect does lead to lengthen attention span or whatever. Okay, so this is going to be a sort of like applied. Okay, how do you apply that to the so the framework, right? Sufficiency economy. Okay, principle, right? Now in our class I applied it to what? Asian financial crisis. You're not going to apply it to that, but you certainly can apply it. Definitely GMOs, right? GMO is a very hot topic. It's a perfect example of situation where you should use sufficiency economy philosophy lens. Okay, for example. So these are all very good. So I would, you know, I would devise a way of asking. Again, I would not ask the pure content. I would say, how do you apply this content to your topic? Okay. Now I could be mean and just to be let's say fair. Okay. In evaluation, I may bring up another topic that none of you has picked as the project. Okay. So let's say I will pick something about, I don't know, quantum computing. Okay. That way your answer will be comparable, right? Because if I ask you about your project, Panpisha is going to be about enzyme and plastic, and Kushi is going to be this radar imagery, and so it's a little bit hard to compare, you know, quality of response. So maybe I will come up with some other example use case. Okay, so in other words, the main use case is your project, but I may come up with auxiliary or a second use case so that I can test everyone. And now that I know which area you guys are, I will make sure that this use case does not match any of the topic that you picked, right? It will be the 11th student, okay? That way nobody has advantage. So that's it. That's going to be what, don't save, I don't need to save that. Okay, Kap. So with that, I think we're done for today. Work hard. Will you send this? I think you have it. I haven't updated since class 12, I think. But I'll send it again. Okay, I haven't updated since before robotics, I think. Okay, so that's the final version. It's the same thing, you know, with every year happen. Okay, so with that, I think we're done for today.